all. Thank you, ma'am, for the welcome note. Now, I would like to invite Dr. Praveen P.S., Junior Scientist, to introduce the speaker to the audience.
Thank you. Dr. Karthika P, presently working as a transportation consultant in Bengaluru. She graduated in civil engineering from the University of Calicut and obtained MTech in transportation engineering from National Institute of Technology, Varanasi. She completed her doctorate degree in transportation engineering from Indian Institute of Science, Bangalore in 2024 under the guidance of Professor Ashish Verma. Her research on microscopic modeling of crowd dynamics in mass religious gatherings focused on understanding and modeling pedestrian behavioral dynamics in large religious congregations.
Our director of NATPAC, Professor Dr. Samson Mathusa, is also here today with us. So let's have a few words from him.
Thank you, Ashika. Dr. Karthika, good morning.
Good morning, sir.
Okay. Welcome to this Trans Tech talk series, TransPedia talk series. I'm happy that you are doing a very interesting topic. And in fact, as you know, we have discussed this topic many times with your guide, Ashish Verma, and in a very small way, probably, we are also entering into that area in Kerala. Next year, our Praveen will be doing something on this topic. Welcome once again to this topic, and then we'll listen to you, and then probably at a later stage we will interact with you. Thank you.
Now, I invite our distinguished speaker to deliver the talk. Over to you, ma'am.
Thank you for the warm welcome, everyone. Please let me know if my screen is visible.
Yes, ma'am, the screen is visible.
Good afternoon, everyone. I'm Karthika. I completed my PhD from ISC Bangalore in 2024 under the supervision of Professor Ashish Verma. My research was on understanding and modeling the microscopic pedestrian behavioral dynamics in mass religious gatherings. So today in this talk, I would like to share some insights from the data that we have collected in field, that is from crowds and also from laboratory studies. So I'd like to give a brief overview of my research, PhD research, before jumping into the specific problem that we will be exploring today in this talk. Moving on to the motivation of this research problem. The World Health Organization has defined mass gatherings as planned or spontaneous event, where a number of people would be attending this event, and that would in turn strain the planning and the response resources of the community or country or the event organizer who's hosting this event. So we are interested in the individual pedestrian behavior in a crowd because you can study the crowd from different scales of representation. You can study the crowd as a whole, where you're looking at the macroscopic quantities, or you can look at the microscopic behavior of pedestrians. So nevertheless, all these gatherings are characterized by the large-scale nature of the event. They have activities that span over multiple days and multiple locations. It's mostly a pedestrian dominated situation, and you have uncertainty about the destinations, activities, routes, and many others. Now, why we need to study pedestrian behavior in mass gatherings? Because it is individual people whose decisions or choices that they make and the interaction with other pedestrians and the environment that translates into the crowd dynamics that as we see. Any study which looks at these kind of research problems or research questions have potentially two beneficiaries. One is the organizer who is in charge of the event, and the other is a participant who has come to the event space to perform certain activities. Now, if you look at the different kinds of mass gatherings, it could be classified into, say, religious gatherings based on the purpose of the gathering, into religious gatherings, entertainment-based gatherings, political gatherings, and miscellaneous gatherings. And it has been shown in literature that religious gatherings and pilgrimages have been venues for about 79% of the stampedes in India. And the map here shows the distribution of human stampedes in India from 2000 to 2012, which shows a fairly equitable distribution across our country. Now, looking at some of the crowd incidents that happened since 2000, a common parameter that is attributed to the crowd situation is the crowd density or crowd pressure that results as from the the crowd surge. But if you look closely at some of these incidents or events that have happened over the years, we would be able to identify certain causal factors that have resulted in an increased crowd density or crowd surge. For example, rumors, inadequate information dissemination from the authorities, people carrying huge luggages, unanticipated crowd flow, narrow infrastructure into which the crowd is forced to move, like narrow stairways or alleys, inadequate infrastructure, intersecting flows where the flows are not segregated based on the direction of flow, roadblocks, and many other such incidents. So these are all essentially triggers for crowd disturbances leading to an increased crowd density or crowd crush. So these are not essentially happening because of the large inflow of numbers alone. The crowd surge could happen as a result of any of these factors. So local disturbances can also result in risky situations in a crowd. Now, if you look at the pilgrims or participants, they would be interested in having a quick, safe, and comfortable journey. They would also like to have the information on, say, the entry and exit points, information on activities, timings, and locations, that is, proper signage regarding the activity locations or scheduling of the events and so on, with access to basic facilities like drinking water and sanitation. And if you look at the crowd organizers, event organizers, they would be interested in having a safe event with stringent crowd control measures in place. They would already have an optimal scheduling of the events which they would like to stick to. Plus, they would have evaluated strategies and emergency plans in case certain things go wrong. Unfortunately, some of these objectives between the participants and the event organizers are conflicting in nature. For example, if you look at the objective where the participant would like to have a quick, safe, and comfortable journey, and this is because most of the participants who come to the event space, they come from they travel long distances and reach this event space, and they would have time constraints and budget restrictions as well. So they would like to complete their journey visiting as many important prime activity centers as possible. But this might contradict with the stringent crowd control measures that the organizer has in place, and also with the optimal scheduling of events that the event organizer has put up with. So in this regard, people have to make choices when they are in a crowd, and the different decisions that people make, they have been arranged into a hierarchy of choices, with the first level, that is known as the strategic level, where you have decisions, higher level decisions taken regarding, say, the destination choice or the activity choice. Then you have the tactical level decisions, where since your destination is fixed, you would like to know what kind of what is the route that I should follow, or the different activities that I need to sequence. So order of activities or trip chaining is something that might come at the tactical level decision. Now, once the higher level decisions are fixed, the operational level decisions, such as the speed at which a person walks, or the direction of motion, all these come under operational level decisions. And most of the pedestrian models deal with the operational level decisions, conditioned on the fact that the higher level decisions are known to the analyst. Now, moving on to a brief, very brief literature review, because there are plenty of studies on pedestrian behavior where people have focused on the interactive behaviors, walking speeds, evacuation behavior, panic behavior, and so on. There are also studies which look at mass gatherings or large-scale events in terms of how crowd management is done, how accessible are the locations, and what are the crowd models and simulations that are out there. Since we are looking at a microscopic level analysis, I would just like to briefly summarize the microscopic pedestrian models that are presented in literature. Some of the most popular models are the social force model proposed by Helbing. You have the cell automata model where you have discretized cells. Discrete choice models have also been applied to understand pedestrian behavior, but not to a large extent. Then you have agent-based models where the agent behaves based on a defined set of rules. And you have other variants. You have hybrid models where you have, combine the features of two models, popular models to make a better model. Another important phenomena that occurs in crowd, and its term that's coined in crowd literature, is called as a self-organization phenomena. And these are the emergent patterns that occur or the collective behavior because of the collective behavior of the individuals, the interactions that they have with each other and with the environment. For instance, you have the lane formation, automatic lane formation in bidirectional flows. You have staggered walking and bottlenecks, walking patterns of social groups, and stripe formation in crossing flows. Now, based on the extensive literature review, research gaps were identified from literature. So in this particular talk, we'll be going through two of the research gaps. One is the factors that influence crossing decisions in pedestrians. In pedestrian conflict situations, this is because pedestrian vehicle conflict situations are extensively studied in literature, but when it comes to pedestrian conflict situations and trying to understand what are the factors that influence this interactive behavior, there have been very limited studies in this regard. We'll also slightly touch upon the group formations and transition of group formations while walking, which is a very less explored topic in crowd literature, but this is conditional on the fact that the time permits me to go through it. The main context of this talk is that we like to understand the pedestrian interactive behavior and see the differences across natural and artificial environments. So for this, we'll use a crossing behavior as an example to derive insights. Coming to the overall research approach and the data that we have used. So from the literature review and observing the video data on the walking behavior of people, we would like to understand what are the factors that influence these walking behaviors. We have identified representative crowd situations, and what we mean by representative crowd situations are conditions like queuing in corridors, segregated walking, crossing flows, bottleneck situations, crowding at activity locations, and many others. So for each of these situations, we try to understand what is the set of walking strategies or maneuvers that people might be choosing. And the basic tenet for this idea is that walking is a very natural process for humans, and people have some familiarity, or they would be able to relate to similar situations in their daily travel and have certain optimal strategies or walking strategies or maneuvers that they would like to implement and that they have garnered over time and through experience. So for each of this, we try to formulate the decision processing mechanism and adopt a suitable modeling approach. And in this respect, we have collected data. Video data is used to understand the pedestrian behavior. And here we have collected data in field, and also we have also collected data using experimental setups. Some of the experimental setups will be discussed in detail. Moving on to the field data. So the field data collection, the case study was Ujjain city. The reason for considering Ujjain city as our study area was that it's a major tourist, religious tourism spot. Because Kumbh Mela, which is one of the one of the largest mass religious gatherings in the world, it happens in India at 4 different places by rotation. And Ujjain is one of the places where Kumbh Mela happens. It happens by the river Shipra in Ujjain. And when you talk about the activities that people can perform when they come to Kumbh Mela, because in a crowded situation also, people are walking or traveling because they want to pursue some activities. And some of the prime activities that people can perform when they are in the Mela region are taking a dip in the holy river, that is the river Shipra. Then visiting temples, you have the famous Mahakaleshwar temple here, you have the Hasiddhi temple, Chardham temple, and many other temples which are of immense religious importance. Then you also can take part in the spiritual discourses and which happen in the spiritual camps that are set up in the Mela region. And then you have processions in which you can take part. For certain activities like processions and for holy day, a few days are considered to be extremely auspicious, and these days are known as Shahi Sman days. So we have collected data of pedestrian movement in some of these locations in the Mela region, and we use that to understand the pedestrian behavior. Moving on to the, some of the video snippets, the image snippets are shown here where you're able to see the field data collection exercise. You're able to see the lack of infrastructure and the challenges that people face when we do field data collection. And this data collection happened in two phases, one during the Ujjain Kumbh Mela in 2016 and the Mahashivratri festival, which happened in 2017. Moving on to the controlled laboratory experiments. These experiments have become quite popular recently to understand specific pedestrian behaviors. So what the analyst does here, or the researcher does here, is to set up an artificial environment and have participants take part in certain activities, or they are asked to walk or move in certain ways, which can be used to represent and model the crowd behavior in the absence of field data. So we also did a couple of these controlled laboratory experiments. So one of them was to understand the stride length of participants. The other one was to understand the effect of social groups. So by social groups, we mean family or friends. They are small groups composed of 3 to 5 members. And then we conducted this experiment in a linear, this corridor. Similarly, we also did controlled experiments to understand the interactive behavior in intersecting flows and single file movement study. So this we will go into detail in the next section. Coming to the main topic of today's talk, where we are trying to understand the difference in the pedestrian behavior across these field and laboratory studies. We try to understand it through a behavior in intersecting flow. So the interactive behavior of pedestrians. So it's important to understand the pedestrian interactions in crowd scenarios, as it has been reported in literature. When pedestrian streams intersect, their conflict of interest in terms of direction of motion, it translates into people looking for gaps or spaces in the crowd to move forward. For example, if you look at this kind of a situation, which we observed in the Ujjain city, where you have a steady stream of moving pedestrians who are walking in a particular direction. And then you also find a very small segment, a small percentage of people whom we refer to as minor stream pedestrians, trying to cut across this moving stream of people and move in their desired direction. So this is very akin to the gap acceptance behavior that is extensively studied in vehicle pedestrian scenarios and in vehicle scenarios at unsignalized intersections or mid-blocks. But this is something that has not been explored as a gap-seeking behavior in crowd. So this is what we do here. We formulate decision mechanism as making mechanism as a gap-seeking behavior. And here pedestrians are basically looking for gaps or spaces in the crowd to facilitate their movement. So look at the field situation. There's a schematic diagram showing the kind of situation there. So you have the major direction of flow here, and you have minor direction of flow here. So the people were initially prohibited from entering into the section B by the event organizers by placing of barricades. In the absence of the security personnel, people started pushing away this barricade and entering into this minor direction and cutting across this steady stream of moving people. So this is a situation that we found and we wanted to investigate. Problem was that this situation happens only intermittently. So it's not a continuous stream of minor stream pedestrians trying to access the minor direction road. And this also happened only for a very short time, because once the security personnel came back into position, they again, strictly prohibited people from entering into the section. So this behavior also, we were able to observe it only for a very short time window, limiting the sample size for us. So essentially, the objectives of this study is to understand, to study the gap acceptance or gap seeking behavior of people in crowd. We would also like to test for the effect of difference in motivation levels. So we are talking about genuine motivation, which is in the field because you are there at the Mela space or the event space to perform certain activities and you are intrinsically motivated to perform those activities. Whereas in an experimental setup, it is an induced motivation that is given by the analyst to the participants of the experiment. So we'll discuss this in detail in the next coming slides. When you're talking about the probability of the choice, the gap being accepted, it is a function of the attributes of the gap. That's again dependent on time t. And then you have the characteristics of the chooser n or the decision maker n. Now, this is the proposed gap choice decision-making process where you assume that you have the person's individual characteristics, including their physical features, their tolerance limit, motivation, and other factors influence the way they choose the gap, in addition to the gap characteristics like the gap duration and other subjective features. So if you look at a gap, the gap can be either accepted or rejected. And if the gap is rejected or not chosen by the decision maker, the evaluation process will continue. In case the gap is actually accepted by the person, there are two possibilities for this. One is it's a mutually acceptable gap where the major stream pedestrian gave way to the minor stream pedestrian to cross, or it could be a forced gap wherein the minor stream pedestrian pushes ahead to reach their destination quicker. And these small disturbances can prove to be triggers for crowd disturbance, and that's why important to understand what are the different factors that influence the decision-making processes in such situations. Coming to the controlled experimental setup, we wanted to see if we are able to reproduce this interactive behavior in a laboratory, in an artificial environment, since we also have a very limited sample size in field. So what we designed was this kind of an experiment in lab. And this experiment was carried out in ISC during Open Day. Open Day is basically an annual event that happens in ISC where the gates are open to the public and they are welcome to understand the research that happens in IISc. So this was it's a very voluntary participation by the people who attended this event, and we designed this experiment in the form of a game so that they'll be interested to take part in it. So basically you have a set of participants at a time who are participating in the experiment, and each of these participants are given an index. A beep sound is sounded when they are moving along this walkway. It's a loop, and the subject participant whose index is called, they have to cross this moving stream of people to perform an activity on the other side of the moving people. So this is how the subject participant is at the beginning of the task, and once there are different gaps that they can choose from, and this is the chosen gap by the subject participants, and we are interested in knowing how and why they are choosing that particular gap, because what we are observing is essentially whether they are accepting the gap or not. So this is the experiment, and we motivated the participants to perform this by offering them gifts. Prizes through a lucky draw, and the condition for that lucky draw was that they had to perform this activity at least once to take part in the lucky draw. So the more number of times they participated in this activity, they increase their probability that much more to be selected in the lucky draw. So this was the experimental setup that we designed to understand this interactive behavior. From the video data, we have to gauge whether it is a gap forcing behavior or not. So these were the three indicators that we used. We are able to see evident pushing behavior, stepping in front of moving line, and using of hand gestures. So we allowed the people to walk as naturally as possible in the experiment, where people normally use hands and eyes to communicate with each other when they're in their daily life while walking. But the compliance, if the person wanted to comply with the request of the minor stream pedestrian, is of course left to the decision of the major stream pedestrian. If you look at the small data description of the two data sets that we have, we see that there's a higher proportion of adults, older adults in the field data when compared to the experimental data. And the mean waiting time is also higher in the field than the experimental setup. Gap forcing behavior is quite more in field when compared to the experimental setup, and you see the compliance behavior in experimental setup to a large extent. This shows how the experiment was carried out in the laboratory and gaps that they were chosen. Now, coming to modeling gap choice. So what we are essentially observing is the discrete response of whether the gap is being accepted or rejected. So 1 or 0, it's a binary variable here. And we would also try to capture the individual heterogeneity because there are two possibilities in which we can model this. One is the base model where you treat each observation as independent. And the case B is when there could be possible taste variations across individuals and you estimate random parameters for each individual. Now, the first case results in a binary logic model, and the second case we built a mixed logic model. Moving on to the results of the model, what we are able to see here is that the older people, they have, the probability of accepting a gap is lesser for older people when compared to younger people, and the gap forcing behavior comes out to be significant in the field data, whereas it does not come out to be significant in experimental setup data that we collected. The position of the gap is an important variable deciding the gap acceptance behavior in the experimental data. Now, if you compare across the models that we built, we, as I mentioned earlier, we tested for the effect of inter and intra-individual heterogeneity. So inter-individual heterogeneity as in if there is a variation in taste preferences across individuals, and intra-individual heterogeneity comes into picture because we have multiple observations of the same individual over time. But when we built the random parameters model with panel effect and without panel effect, we were not able to see a significant improvement in the models by treating this individual heterogeneity as random parameters. For the further analysis, we'll use only the pool model or the binary logic model. So it's important to do model validation, and in our case, we did model validation for both field and experimental data. In case of field data, because of the limited sample size that we had, it was not possible for us to do a holdout validation. So in this case, we did what is known as a resampling method of internal validation, known as a bootstrap method, where we essentially draw B bootstrap samples from the original data sets with replacement and build model on each of those data sets, and then we report a bootstrap prediction error estimate, which is reported here, where you have this indicator variable Q capturing the measure of error between the actual outcome and the predicted outcome. So if the actual outcome is same as the predicted outcome, this value tends to be 0 and 1 otherwise. And we also report certain other performance measures which can be used for internal validation. We report the first preference recovery, which is the percentage of correct predictions in the data set. And we report also what is known as a Brier statistic. So here you have the expression for Brier statistic, which is basically a measure of the kind of measure of the mean squared error term here, where you're using actually the probabilities instead of the discretized outcomes based on the probabilities. And this helps us to understand the discriminative ability of the model to distinguish between the ability of the model to give a higher probability for the choices that are actually chosen by the individual. Coming to the experimental data, we did holdout validation. So validation data set was about 25% of the data set. And we are able to obtain a decent performance measure for the predictive rho square and the predictive log likelihood values in the validation data set. So coming to the major inferences, where we try to understand the factors influencing gap-seeking behavior. In the field, what we found is that the most significant variables were the gap duration and the gap forcing tendencies. With respect to individual specific characteristics, age and luggage are used in the model, but age is a significant variable, old age. Then model validation is performed using bootstrapping method with a Brier statistic value of 0.21, and we are able to see a lot of competitive behavior in the field data. Now, if you look at the experimental data, on the other hand, we see that the most significant variables are again gap and the relative position of the gap. The gap forcing is not significant in the experimental data, and none of the individual specific time invariant characteristics were significant here. We did model validation here and report a relative error of 2.18%, and we are able to see more of cooperative behavior compared to the competitive behavior in the field data here. So essentially, it seems like there's limited reproducibility when it comes to reproducing this kind of a pedestrian interactive behavior in field, in laboratory, in experimental conditions. Now, would also like to briefly touch upon another experiment that we did to understand the effect of social groups. So social groups are essentially family or friends who come together to attend this particular event, and group formations, that is a way the spatial arrangement of the group members is something that is explored less. So we did an experiment to understand this group formations, and we did this using in two ways, in different scenarios, one without social groups and with social groups. So without social groups, we did this experiment with a set of participants of 20 and 30 participants, and then we had with social groups, where we split the participants into and designated them into social groups of 2 members and 3 members. And this is how the experiment was carried out. And we obtained different patterns or spatial arrangements of groups. So here you see what is referred to as an inverted V formation with the center pedestrian leading the group. You have a proper V formation where the middle person falls back a little. You have the line formation where all of them are walking side by side, and you have river formations where they walk in a line. And we looked at how these formations transition over time. So basically there is a trade-off that happens between ease of navigation and the amount of verbal communication that you can have, or the interaction that you can have with the group members. So these are some of the results of the study, where you see that, as the group size increases, the speeds come down, and this shows the formations, different formations across different runs. So I'll not go into the details of this. So essentially what we found again through this experiment was that it is difficult to distinguish the behavior of people in terms of whether they're actually behaving as a part of so let's move on to the challenges that we have identified with respect to both of these situations, field situation versus laboratory conditions. So in field, it allows the analyst to observe the people in a natural environment without any external influence per se. And it's an undisturbed scenario that you're observing. But observing and capturing specific pedestrian behavior with minimal external influence becomes difficult in field. Whereas in laboratory, it's possible to explore specific pedestrian behavior in isolation, but we need to understand if the pedestrian behavior is getting significantly altered in controlled experimental conditions. Are the behaviors being masked, indirectly masking or controlling the individual heterogeneity among the people? Because we are not able to observe the extreme behaviors like pushing behaviors, overtaking behaviors. All these are very subdued in the case of experimental setup, where the participants conform to the average behavior of people, probably because they are aware that they are being recorded, their actions are being noted by people, which is not the condition in the field. Coming back to the field data, we have inadequate resources, inadequate infrastructure, as some of the pictures showed. With respect to camera positioning, we have plenty of issues, as you were able to see. Improper volunteer coordination, administrative difficulties, privacy, timing issues, logistics, weather, and many others. The laboratory conditions offer distinct advantages in terms of some of these. For example, ideal camera positioning is something that you can accomplish when you're setting up an artificial environment in a laboratory. You have effective volunteer coordination and better control over weather and logistics. However, there's a lack of realism in the environment that will affect the way people behave when they are in the laboratory. Of course, again, this would have privacy and ethical concerns, mostly because if you're trying to capture behavior of people in evacuation or panic situations, it has its own safety issues. And last but not the least, it's found to be difficult to instill the pedestrians' inherent motivation in a controlled experiment, which is quite evident in the field data. So these are some of the challenges, the pros and cons of both the approaches of data collection, video data collection. We have tried to understand the pedestrian behavior. Coming to the conclusion, basically our work attempted to develop a set of empirical models for representative crowd situations capturing the decision-making process. We calibrated and validated this on-the-field data to improve our understanding. We propose modeling the crossing behavior as gap-seeking decisions of pedestrians in a crowd, which can be used as inputs to improve the lane changing and gap acceptance models in pedestrian simulation. Moreover, we provide a new experimental configuration to study the gap-taking behavior of pedestrians in controlled setups. However, all the models that we have developed in this thesis represent pedestrian behavior in normal, non-panic situations. We also had issues in priming the participants to inculcate motivation to perform activities, despite the fact that we did a demonstration. We had a trial run for the participants to ensure that they understood the instructions properly and carefully, and we make sure to to avoid any bias from our side to influence their behavior. Still, we were not able to inculcate that intrinsic motivation to perform that urge to do activities in an experimental data. When it comes to group behavior, we have not been able to study various classes of social groups in the experimental data, and we were not able to include the influence of group behavior on gap choice decisions, primarily because of the issues that we had in terms of data collection and data extraction. So with this, I conclude my presentation. These are some of my reference journal publications. I would like to thank Professor Ashish Verma for encouraging me to do research in this particular area. The Department of Civil Engineering, IISc Bangalore, current and lab alumni, funding agencies. Last but not least, the volunteers who willingly took part in my experiment, and the interns who helped me in both data collection and extraction. I would like to acknowledge the help rendered by all of them, including my family and friends. So thank you. I also thank NATPAC for giving me an opportunity to present my research work. A special thanks to Dr. Praveen for inviting me over. Thank you.
That was a nice presentation. Thank you, ma'am. Now the forum is open for discussion.
Yeah, Dr. Karthika, it was a very nice presentation. This is Praveen. I'd like to have a query regarding how the heterogeneity in while doing experiments with pedestrians in the lab was maintained. Like, for example, if we manage to find the pedestrians in the lab, say for around 24 hours or so, they might get accustomed within the groups, right? So, but in case of the field, that may not be the scenario. Like random people will be meeting up random people. So how was that thing simulated in case of laboratory?
Yeah, thank you for the question. So essentially, in two of our experiments, we used student volunteers. So there was not a lot of heterogeneity in the data, but that experiment was done to understand the effect of social groups. So we had volunteers in the age group of 20 to 40 years taking part in the experiment. And they were not exactly lab members or people who were in IISc. They had come from different colleges, and they were they were asked to take part in this experiment. So there's not a lot of heterogeneity, but that did not matter in that particular experiment, because we were looking to understand the effect of social groups, and if they are in the same age group, we hope that it could promote that social group behavior, interactive behavior for that matter. But in the gap choice experiment that we carried out, there was actually a lot of heterogeneity in the population that took part in the participants, primarily because the experiment was done using visitors, public visitors who came to the department to for the open day experiment, for the open day. So there you have a wide range of people. You would have people from all age groups, including small children. You would have school-going children taking part in this experiment. Then you also had college-going people, middle-aged people, people who come families who came with children and parents. So there was a lot of heterogeneity and they did not know each other. So that situation was very similar to the field situation. But despite that, what we noticed was that people tend to behave in a very controlled manner, where they're not exhibiting their actual behavior. So in field, you're not bothered whether you're being recorded or someone is noticing you pushing or squeezing others in the crowd. Whereas in an experimental setup where that there are people standing around you from a department who's actually conducting this experiment in the form of a game, but they are very sure that others are watching them. So it translates into kind of subjugating their own behavior in experimental data.
Thank you.
Hello, this is Shahim S, Principal
Yes,
Scientist
sir.
from NATPAC.
Yes, sir.
So I have a question like, how you can apply this to other cities or some, how you have to generalize this study, your study. And the next, second one is, there is some problem with the drivers' behavior, attitude of the drivers. So that did you consider for your study? Yeah.
Okay. So I think the first question is regarding the transferability of the model or generalizability of the model. The proposed model, it's a very simple model, and if you want to actually try to understand this gap acceptance or gap seeking behavior in another setup, I wouldn't say that you can use exact same parameters as the calibrated parameters in this case, but of course it's easy to collect. If it's possible to collect data, then you could actually use the similar kind of variables that came out to be significant. Plus, if you're able to get more variables, you can build a simple model to understand the behavior. The second thing is regarding driver behavior. No, we have not considered driver behavior, or we have not considered the interaction of vehicles with pedestrians in my case.
Okay, then you have in the controlled experience, you have taken out 3 pedestrians. Why you take 3?
You're talking about the social group experiment, sir?
Yeah, correct.
Yeah, so social
The
groups,
laboratory experience.
basically they are groups of 2 or 3 members, or 4 or 5 members at the most. So the purpose was to see how people arrange themselves. So it is usually seen that even if you're larger groups, say 4, 5, 6, and so on, they tend to split into subgroups of 2 members or 3 group members each. So we have not explored if the behavior is significantly different for larger groups in this experiment. But again, if you have larger groups, there is a high probability that they'll split into these smaller groups and then move as subgroups by themselves.
Okay, okay, thank you for the nice presentation and your reply. Thanks.
Thank you.
Hi, I'm Vasudevan, junior scientist from NATPAC.
Yes,
it was a nice presentation. So I have a couple of questions. First of all, what is that motive of estimating this gap acceptance behavior? Whether any crisscrossing happens or from this minor stream to major stream, or will that be leading to any safety issues?
Yes.
Or what can be the motive behind finding out this gap acceptance behavior? And do you find any critical gap values or something threshold values which we normally see in traffic scenarios? What can be the accepted gap and rejected gap? Is that analysis has been conducted, or it is that? And this will also vary with age groups or vary with different categories of people. So how will you address these? Thank you. Yeah.
Thank you, sir. I think your question is on the motivation, like why are we studying this gap acceptance behavior? So I believe I mentioned it, but the reason is that the crowd disturbances, whatever crowd stampedes or incidents happen, they are not always a result of the crowd density per se. Small triggers or local disturbances can often result in situations that can get quickly out of hand in field where there are a lot of people. And if you're actually moving in a streamlined path, and there are people coming, once in a while, and they are asking you to break your movement and let them pass. So if that does not happen, and there is, what you call pushing behavior, forcing behavior on the part of the minor stream pedestrian, this could result in situations where there are, turbulent situations that are created within the crowd, and this could escalate actually. And it has been, it's been a lesson from the past that it's minor issues sometimes that actually escalate and lead to uncontrollable situations resulting in fatality. So that is the reason why we wanted to explore this behavior. Also, because in most pedestrian simulation models, the way the gaps or spaces are chosen are sometimes quite rule-based, whether you give sometimes a 50-50 probability to assign a person to particular space. And these models could in turn be implemented into pedestrian simulation models to, get the probability of choosing a particular gap. So that was a motivation for pursuing this research problem. And yes, age plays a significant role here. For the experimental setup, though none of the individual specific characteristics came out to be significant for our data, but in the field, we were able to see that individual characteristics definitely influence the way people choose these gaps. So gender was not significant at 95% confidence level, so we did not report that result here. But luggage influence, because most of the people who come to attend such events, they come carrying heavy head luggages. And this definitely plays a role in how they choose their gaps. Also the age, if the age is more, so elderly people find it difficult to cross the gaps compared to younger people, is our observation in the data. And yes, we did not find the critical gap. I think that was your last question. We have not found out the, and we have not done the analysis similar to the vehicle. Sorry. In the vehicular situations where you find the critical gap, no, that we have not done that.
Okay, yeah. So basically, this is actually crossing a major stream by the influence of this minor stream, right? This is simply a crossing that particular major stream with considering, for example, if we talk about the traffic scenario, we normally choose the acceptance for crossing the entire width of that corridor or the street. Here it will be a particular streamlined, right? So will that width be effective here? Is there an influence of that pattern? Or what actually the scenario in the field? It will be a mostly a streamlined path, right? So will that this gap?
Could you repeat your question, please? It's not clear to me.
Basically the width of that particular stream, for example,
Yeah.
the width of that major stream, will that be influencing in gap acceptance behavior for minor stream people? Because normally what happens if the width of the stream is higher, then that gap acceptance will be influential, because he has to wait for some time, then he will look into the vehicles and he will cross it in case of traffic. But here people are moving from one side to another side with a barricade or some controlled level, right, in the experiment, I mean in the field. So will this gap acceptance be influenced by the width of that particular stream of measures?
I think it'll be influenced by the space that is available for movement on the other side, in terms of how the barricade is placed and the width of the minor road as well. But a thing that we noticed, I think there's something that's quite common also, that people often walk parallel to the stream for some time and cross when an opportunity presents itself. So in that situations, it might not be exactly the the width of the minor stream that matters. It would be the duration or the gap width that matters to the minor stream pedestrian.
In that case, but it will not be any force gap behavior, right? Then the force gap concept will not be applicable over here.
Force gap would happen if you're not given, if you've been waiting for a long time and you're not presented an opportunity to cross across, force gap situations can arise. That's what we have observed, and that's what the model also shows.
Okay. Yeah, thank you.
Thank you.
Any other questions from the participants?
Karthika,
Yes, sir.
yeah, a nice presentation.
Thank you, sir.
Yeah, good. See, like to this continuation of Dr. Vasudevan's session, I have a couple of these things. So whether the other traffic parameter relations which are existing for the vehicular traffic, whether it is applicable for this case also, have you, whether you have studied anything of that type, like with the different densities, different flow conditions, etc.
So your question is whether we have studied pedestrian behavior for different flow conditions, is it?
Yes, sir.
So we have done a study where we looked at the macroscopic flow parameters like speed, flows, and densities, and we looked at how this is different across different flow conditions, as in unidirectional flow, channeled flows, bidirectional flows, approach road intersections, and others. And we have drawn the pedestrian flow diagrams for each of these sections. And of course, it's very different for different conditions. For example, in regions that are very close to cart regions, which are the places where participants take holy dip. So these regions, the normal behavior that you would expect, where the speeds would decrease with increase in density, is not something that is seen. You see a constant a band of speeds over a range of densities. So yeah, there have been very contrasting observations from the field data when you look at different flow conditions as well.
Okay, fine. My this one is in the case of this the pedestrian flow. Do you think that the age is one important factor? Of course, if you are taking the flow parameters for any spiritual or this type of activities, or maybe if it is for like a cricket like a match, or maybe for a music program and all, the behavior will be the crowd behavior will be totally different, no?
You're speaking with respect to the kind of crowd that comes to attend the
Yes,
event?
yes.
Yes. I believe it will be different because they are a different category of crowds called as the spectator crowds. Other than the crowds that we have studied, which is a mass religious gathering, where there is a lot of activities that the people themselves perform, which is quite different from the situation in a stadium or a concert where the participants are usually mute spectators rather than performing activities. I think there it would be more appropriate to look at whether the event space can accommodate the inflow of crowd. And I think signages, important information that need to be displayed, entry, exit gates. I believe these are some of the things that people keep in mind when you're looking at these kind of crowds.
Is there any the provision, the codal the guidelines are available either in India or in the international? Is there any such guidelines are available?
So we have, I believe, the NDMA report, National Disaster Management Authority's report, is available, which can serve as a guideline for such event organizers. And abroad, several countries have their own standards on the permissible crowd numbers. I mean, the number of people who can attend such events, and there are certain regulations in place. But in India, I think it is the NDMA report that is commonly used. That's the guideline.
Only the NDMA. Okay.
Yes.
How will you compare your work, or can be a part of that lesson on our highway capacity manual? Indian highway capacity manual, no? They need to have consider a pedestrian section. Okay. Whether your the research output can contribute something to that HCM manual also.
Yes, I think where you have exclusive pedestrian facilities, you don't have, say, the level of service measures, I believe, available for, and other than for footpaths or crosswalks. So, for example, facilities like pedestrian-only streets Or if you also look at facilities like you have barricaded corridors, which is a common way to handle crowd in mass gatherings or mass religious gatherings. So you don't have any guidelines regarding what is the best level of service for those conditions. So I think yes, we have done a couple of studies in that regard, and they can be used to understand and derive insights on level of service of the facility that is offered to the pedestrians in that situations.
Okay, the last question. Like you must be knowing the special, the certain special, the activity, like the religious activities happening in Kerala.
Yes, sir.
Is, like our Trivandrum, we have that Bongala, Atigal Bongala. Even at a minor level, we have the temple festivals, different locations, or maybe the Guruvayur related activities, or and the Sabarimala activities and all. What will be your suggestion and how, what the type of studies of the investigations which we should do that one to manage this crowd? Where exclusively only the pedestrians or the people movement alone is happening.
Well, that's a very tricky question because each of these gatherings have their own unique characteristics. And if you look at
one more Thrissur Puram also.
yes, sir. So if you look at Bongala,
yeah.
I think there's a lot of traffic related issues there anyways happening. Then of course managing the space for people to perform their that particular religious activity. Plus there's also the queue that happens to visit the temple where these devotees walk to the temple. So there are several aspects I think that we need to consider, and I think it's very important to have an on-site inspection to see what are the actual challenges faced by the organizers there, and then decide rather than because what I have read in certain studies by researchers who have worked on this field for a long time, their insight is that rather than developing models, I'm not saying models are bad, but it's very important to see the actual site situations and see how you need to handle it before depending completely on models. So one thing would be in segregating the direction of flow. The other would be in terms of important information that needs to be disseminated to the people. And if real-time information can be disseminated, I think that would be a very good option to help the pilgrims or devotees in taking part in these events. Similar to other places where you have darshan timings and you can actually pre-book these. I don't know if these facilities are available right now. If these kind of situations are implemented right now in these temples, but that is one possibility that we can think of to manage the crowds better. You have pre-bookings and then you need to come only at that allotted time and visit. So that can reduce certain, the longer waiting times and queues that can happen. And of course, we have simulation models where you would be able to see for what time you need to say stop a set of pedestrians for some time before releasing them, and how long the queue would build up, and would that be manageable or not, if the waiting times are, how are the waiting times being affected because of the darshan timings and so on. So I think there are several aspects that you need to consider at the same time, and I think it's a very challenging topic, to be honest.
Okay, thank you, Karthika. Probably Dr. Praveen, he'll be in touch with you. Probably can help him. We also like to do some preliminary studies, and then probably we wanted to extend to this the locations. Thank you. Thank you for
thanks.
Now I request Dr. Scientist to propose the vote of thanks.
Good morning, everyone. On behalf of NATPAC, I would like to extend my heartfelt gratitude to each one of you for joining us today for the TransPedia research talk on the topic Understanding Pedestrian Behavior, Insights from Crowd and Laboratory Studies. First and foremost, I would like to express my sincere gratitude to our esteemed speaker, Dr. Karthika P, for the interesting session on crossing behavior of pedestrians in mass gatherings. Dr. Karthika, your detailed analysis of the pedestrian movement dynamics, especially within crowded environments, has not only shed light on critical aspects of event planning and crowd management, but also provided a deeper understanding of the complexities involved in the decision-making process of the pedestrians. We are grateful for the knowledge you shared with us today. I would also like to express my gratitude to all the attendees for your presence and active involvement. I would like to thank our director, division heads, and the organizing team for the support that made the smooth execution of this program. In conclusion, I believe we have all gained valuable insights from today's technical talk, deepening our understanding of pedestrian behavior, which will undoubtedly contribute to enhancing safety and efficiency in urban planning and crowd management. Thank you once again to everyone involved, and we look forward to hosting more technical talk in this series and continuing this legacy. Thank you all and have a great day ahead.
Thank you.
Thank you, Karthika.
Thank you, sir.